The vast universe is filled with strange and mysterious phenomena, from quasars and black holes to the Buddha's void. One bizarre element in space is rogue planets, worlds just like our own, untethered by a star, wandering free and alone through the abyss. Could one of these lonely planets find its way to our own solar system or even collide with the Earth? Rouge planets, also known as free-floating planets, are thought to be a result of gravitational interactions in the early days of the formation of solar systems. Or they could be a result of the failed formation of stars. Modern theories of planetary system formation suggest that many planets are formed around young stars when they are in the short-lived phase of growing their planetary systems. But many of these are ejected due to gravitational scattering as the planetary systems organize themselves over time. Michael Zemkov, an associate professor of physics at the Rochester Institute of Technology, told Newsweek. As a solar system forms, numerous chunks of rock of varying sizes and speeds whirl around each other in chaotic orbits. As these bodies soar past each other, they alter the orbits of other bodies as a result of their gravity. In typical three-body interactions characteristic of these ejection events, it is usually the lowest mass object that gets ejected, Zemkov said. So I think a generic prediction of these clearing out episodes during planetary system formation is that the heavier objects, whether rocky or, more likely, ice or gas giants, survive, and the smaller ones don't. Rogue planets may also come from another source, which is a star that failed to ignite and instead became stuck as a lone gas giant. They might form out of gas clouds in space, in the same way stars do, or they may have formed in a disk around a star and then been ejected due to an encounter with another star or an interaction with another planet in the same system. Richard Parker, a lecturer in astrophysics at the University of Sheffield in the UK, told Newsweek. In the former case, they are likely to be predominantly gas giants like Jupiter. In the latter case, they could be rocky like Earth, he said. Scientists aren't sure how many rogue planets are in our Milky Way galaxy, since they are extremely hard to observe. There are likely many billions or more, but they are ferociously hard to see, Zemkov said. They would emit very little light on their own, mostly at very long wavelengths that are extremely difficult to pick out of the background emission. As a result, our primary way of detecting them is via gravitational microlensing, where we monitor a field of stars and then look for the light of a background source being temporarily magnified by the mass of a rogue planet as it passes precisely between our telescopes and the background star. He continued, "We have found many objects this way, but without other information, the lensing objects are impossible to weigh. So we don't have a good idea of demographics, except in the general sense that larger things should be easier to see just because their temporary magnification is brighter and longer." While we don't have a true idea of the number of rogue planets, scientists expect it is large. "We expect a really big population," Alberto Ferrain, a planetary scientist and astrobiologist at Cornell University, told Newsweek. "Think this way. The smallest, the object in our galaxy, the larger the number of them we expect." According to Dorian Abbott, a geophysical sciences professor at the University of Chicago, it is likely that most rogue planets are terrestrial because there are probably more terrestrial planets in general. It's easier to throw them out through an interaction with a gas giant because they are less massive, but gas giants can be ejected too. The hot Jupiters detected in around 1% of systems suggest major dynamical evolution of those systems, since Jupiters have to form where it is cold. This dynamical evolution could be associated with generating rogue planets, Abbott told Newsweek. With all these invisible planets zipping around the galaxy, could one enter our solar system or even collide with the Earth? Assuming that there is a rogue planet for every star in the Milky Way, and we assume the solar system will be in a similar region of the galaxy over its lifetime, then I would estimate that the likelihood of a rogue planet coming within the solar system over the next 1,000 years to be a 1 in a billion chance. Garrett Brown, a celestial mechanics and computational physics researcher at the University of Toronto, told Newsweek. Here, I define coming within the solar system to mean that we could see the rogue planet in such a way that when we look at it with a telescope, it would look like Neptune or Pluto, Brown said. For a rogue planet that were to come at least this close, there would be a 1 in 2,000 chance that it would directly alter Earth's orbit. He continued, "It's difficult to say how likely it would be to actually collide with Earth without a more detailed analysis, but it would be much, much less likely. Thus, I would estimate the likelihood of a rogue planet coming closer to the Earth than Mars or Venus to be 1 in 2 trillion in the next 1,000 years. If there is one heading our way within the next 1,000 years, it would currently be about 0.2 light years away. Even if a rogue planet came close to the Earth, the interaction may not even destroy the planet if there wasn't a direct hit. It would need to come close enough to Earth to either collide with it or, a bit less unlikely, alter its orbit. If it does collide, this would be at high speed and likely destroy Earth, if it is comparable in mass and density to Earth, Jaco van Loon, an astrophysicist at Kiel University, told Newsweek. A planet like Jupiter might even swallow Earth, or Earth might come out the other way if it is a grazing encounter, but probably without its atmosphere, he said. Rather than destroying the Earth, a passing rogue planet could even bump our planet out of orbit and cause it to become a rogue planet itself. I would say the more scary thing, rather than a direct collision, is having the Earth be scattered by a brief encounter by, say, an exo-Neptune passing through, which would move us to a different orbit or perhaps eject us from the solar system altogether, Zemkov said. Then we would likely all freeze, or possibly cook, in a matter of weeks. That said, I am not losing any sleep over such a possibility. It's very unlikely that interactions of the planets already in our solar system could suddenly boot Earth out into the abyss, thanks to our planet's orbits having had billions of years to settle into an equilibrium. One open and extremely good question is why our own solar system has been stable over 4.5 billion years, Zemkov said. In many ways, it shouldn't be. As an example, some models for planet formation suggest that Jupiter was formed much closer in and then somehow migrated out to where it is today, likely by exchanging momentum with something that got ejected from our solar system, he continued. How we might retain the 4 rocky planets in the inner solar system in such a scenario is a complete mystery. And then we look around our solar system and see evidence for massive disruptions. For example, Uranus rotating on its side. And it's clear that over astronomical time scales, the details of these solar systems are not terribly robust. One possibility is that there were once more planets in our early solar system, but one was ejected as a rogue planet, leaving the solar system to never return. What's possible is that our sun would have ejected a rogue billions of years ago, when Jupiter and Saturn traveled from their original inner orbits to their actual positions. That's a scenario we cannot discard, but we cannot confirm either, Fehren said. Could a planet be ejected after life has evolved on its surface? Or could life evolve after the planet left its star? Another much more interesting to me possible feature of rogue planets is the possibility that they can host life. Lorenzo Iorio, an astronomy and astrophysics professor at the Italian Ministry of Education, Universities and Research, told Newsweek. Even without a star, life could be sustained under certain conditions. According to the Planetary Society, if a rogue planet had a large moon that orbited at close quarters, it could keep the center of the planet hot enough so that life could exist in volcanic vent environments. So, while a rogue planet's collision would likely spell the end of life on Earth, Such planets may be capable of hosting their own unique ecosystems. Thanks for watching. To stay updated on the latest discoveries, make sure to subscribe to my channel and turn on notifications.